And in that spirit, let's just talk about Buckminster Fuller's world game. The first thing is an analysis of his chapter and critical path about it. If we were to sort of stand back a little bit and just sort of think what are some of the main takeaways, like sort of distillation of his particular use of language, the three things that I think stand out the most are, so the first thing is he sort of advocates for computerizing the world. The first line contains something about software, to the degree that he knew that word. But specifically, and there, it goes back into his history. He proposed an idea for a world resources inventory of human trends and needs. And basically, you would need, in this chapter, he sort of semi-references it, but you kind of need a super large database of anything that you consider a resource. So even like PhD students or electricity generated per hour or the amount of wheat, et cetera, and so on, like the CIA World Fact Book kind of on steroids. Now, one of my logic professors told me it'd be like Wikipedia, to some sort of max where they've got articles on so many things. So there is some precedent to this in a world game, a video game world. All those blades of grass in the games are programmed in to some degree. The universe ostensibly is keeping track of every atom. Computers can keep track of all binding, my voice and these images. The computers are keeping track of that flawlessly, more or less. And I think the basic argument is that something like world resources inventory is required for optimum resource management. Without records, there is no management. If you don't know it exists, you can't do anything about it, more or less. Data is basic to consciousness, and more data, more consciousness. In effect, he's kind of arguing, Fuller, that if you can design the planet as an efficient metasystem that's managing this database of resources. And I just did this morning, refer to the world in computer architecture terms, because I found it to be fun, but also maybe useful. So for example, you could imagine world game is an operating system. With respect to the world resources inventory, it's kind of like a hard drive, of where all the data is. So the world resource, an advantage of the inventory would be to the degree that, eventually, asymptotically, total knowledge of supply. And then in terms of this human trends and needs, then that would also be asymptotically total knowledge of demand, in terms of supply and demand. So in terms of, exchange of resources, travel, votes, all that stuff you're keeping track of in the database, you can do feedback loop optimization so that you increasingly manage the resources better, et cetera, and so on. That's one part, big database. Second part is, you can really play with this giant database through simulations. So certainly video games are fundamentally simulatory. When I see the blade of grass in the game, there is no blade of grass, right? That's a simulation of it. Fuller talks about design science and sort of a design science revolution. Well, you could only really effectively do a planetary level design science when you're sort of compressing the big data of the whole planet, like an architect's, scale modeling, right? You can't actually see the whole building, but if you can scale it down, right, like they do. So ostensibly, I think that this would be kind of a problem-solving engine for any world scale problem, and I'll talk more about that. So again, number one, big database. Number two, simulation, to sort of see how to do things in the world in a more effective way. And then if you, the final step back for the chapter would be, you could really consider world game kind of like a world brain, constructing a world brain, in as much as a database. The brain kind of stores things in the neurons, right? And these sort of simulations, right? You could think of them as a neural network and the thoughts that those networks produce. It's a loose metaphor. It's not intended to be super serious. And you could then, if you want to continue it, you could say players a world game would be sort of like this world mind, executing on these selected thoughts, these selected simulations based off of the total world resources. So I think it's a very interesting idea, this world game chapter in Critical Path. So if you have this sort of world game operating system, and then you have this sort of world resources inventory hard drive, it lends itself to sort of a new economy that, again, if you want, you could think of it maybe as like the central processing unit of the giant computer. So Fuller, the quote is, you want to introduce automation wherever feasible. So in effect, my understanding of his proposal is that you take this giant database of all resources, and then you had introduced automation, so like automatic machines or robots or whatever, for the production, harvest, to sort of dealing with the logistics of these resources, right? Instead of people doing it, instead of like people taking the wheat, just make machines do it automatically. And he invented, right, I think it's in previous and Critical Path, the automatic cotton gin, right? So that would be the idea. And what you would then do is you price the electricity, right? You could pretty accurately measure the amount of electricity from start to finish if you have these components of what it takes to make a cup of chai, from the actual growing of the plant to the harvesting of it to the etc. and so on, to getting the chai in my hand. So I like to think about this in terms of these sort of nutrition facts of food. If you were to think of what would be an accurate economy in terms of pricing, et cetera, and so on. So, you can see ingredients of food, right? And, that'd be like how much tea in the world is there in reference to this one cup of tea. And then, you could measure the amount of energy it took to produce it, which would be like the calories, it's not like exactly, there's a 240 calories for the cup of tea or whatever it is, but it's pretty close. We allow that standard. So you would have maybe something like an AI optimizing, the machines, et cetera, and so on, with respect to the total supply of everything. So this world game operating system would manage, you could again call it like software of actions. So if I like buy something that's in a computer, it might be like some sort of software running or something with respect to the hard drive and with respect to the CPU, which is, so you could then think of the economy now and in this sort of proposed future as just a series of requests. I request a cup of tea, I request a plane ticket back home. This CPU handles those requests. The economy handles it, and it's doing it through these machines with respect to total supply, and it's sort of keeping track of demand, and it's keeping track of the production of all of these things. So I would characterize it as sort of quasi-computerized communism plus a game. Marx talks a lot about the means of production, but you basically can't accurately put value on a person's labor. Why is my labor worth $25 an hour versus this person's worth $100 an hour, right? It's difficult to do that in a fair and just way, but you certainly can measure the electricity pretty accurately, objectively, without subjective problems like that. So I think that really addresses a lot of Marx's issues. Keynes or Smith, whoever you want to talk about capitalism, I think this game component also goes a lot toward addressing, the people's productivity. So instead of, I talk about it later, but yeah, so essentially, I think Fuller's version of a better economy that's computerized is rooted in the most accurate measurement a reality of supply, production, and demand through these components as outlined. So then he talks about this sort of world energy network grid. So again, you've got all these things. I would characterize the network grid as sort of like the motherboard of the computer, the circuitry of how the electricity is actually running. So it seems like just a way to implement this new economic system based on kilowatt hours. It immediately addresses certain least developed areas by developing their grid. It's obviously more efficient in terms of energy and peak load demand, where the sun is shining on half of the planet and not the other half. It creates a shared machinery where you don't want Ukraine bombed because it's part of this network, and you don't want any part of the global network to go out, right? So there's a shared interest that everybody would have. And it's similar to a human nervous system, so there's electricity running all throughout all of our bodies that allow for fine motor movements, and more or less everything else. I mean, electricity is fundamental to consciousness. So after all of that, then he also does talk about sort of a universal basic income. And this was a little bit of a stretch, but you can maybe think of it like random access memory, sort of a specialized extra part that just allows for faster, for the user, essentially. You set aside a certain space in the computer for local activities or whatever it is. So as a part of the, and I have citations in the back that for anyone who's interested, but he's basically saying you pay people to stay at home and then also to watch educational TV. So yeah, it saves the planet money on petroleum. There's been problems recently with viruses, and there was one still circulating today that Fuller had a problem with. These viruses are solvable, like in a complete and total way, because viruses need a host to infect, and without someone to infect, eventually they'll just sort of wither away and die. But capitalism cannot incentivize this quarantining behavior correctly because of this drive to participate in the market. You have to be buying, you have to be selling, right? Whereas this sort of series of things from all the way from here to there that Fuller's proposing could, you could see how that could easily incentivize the type of behaviors necessary to knock these things out. And it wouldn't take 3 years, to knock these things out if you were to do it carefully and efficiently. So furthermore, the abundance in reference to solar energy and everything else is so high that providing like a small fraction of energy, 24 hours of electricity for so many devices for a single family home or whatever it is, it means nothing relative to the total amount of energy you could be harvesting. And so you do want sort of a capital investment for like space programs to, go to distant planets and stuff like that. And giving people a UBI wouldn't really do anything to that. So again, back to the nutrition label, it's like you need 2,000 calories a day. So you could have some standardized amount of electricity that any individual is able to get, maybe based on the age. I'm not sure a baby needs as much electricity. So in like universities give scholarships, they give dorms, meal plans for students. Fuller talks about a fellowship to think, right? So in effect, this sort of university, which we'll talk about more, and this sort of world game becomes the core loop of society, rather than the market, again, which is anywhere on the earth right now is kind of the core loop. And this was the part that I missed earlier. So it's like, I would argue in reference to Keynes or Marx or whatever, that this is sort of and Fuller argues, I think, demonstrate competence economy versus sort of a warring over arbitrary scarcity economy. It is slightly arbitrary that, all the oil's over here, all the gas is over there, or whatever it is. And he talks about that at length in the chapter. So there's also, in reference to all these components, an educational piece that he talks about just in this one chapter. But it's much more fleshed out in the education automation book, which he had put out previously. But in effect, and I'm doing some of this from memory, he suggests that universities should really be relegated to graduate students and professors who are putting out videos like this here, right, in which everybody else can watch, right, and learn from. And it may be more effective for the professor. It may actually be even more effective to learn that way in certain situations. So this might be like an ultimate Wikipedia plus YouTube. You might even want kind of a more formal top-down internet. You know, the internet now is full of like stuff that isn't necessarily useful in any sense at all. And so this might be something that would be better and something that you could get a consensus on, or you have separate internets or something like that, or whatever, gateways. So we already have massive open online courses, and all these Zoom things is sort of very promising for this idea. And certainly it seems like this education, I said the education component in the computer might be like a graphical user interface, right? Where it's essentially telling you how to operate the computer, you know, Finder or the Chrome icon. It's telling you, how, you know, through visual and text, how to use things, which is essentially education. The GUI teaches you, and hopefully, you know, immediately, right? That's why there's whole user interface designers and stuff. But anyway, it seems like this system is really, the education system is married to the economic system and to a democracy. It sort of seems like he's really talking about all of this in a whole. And if you remember at the very beginning of Critical Path, there's that synergetics quote about, you know, real critical paths or like omni, you know, spirally and pulsative and tidal. So they are connected, I would say. And the universal basic income assumes studying, having a population who can understand this new computerized world is very important. Less physical labor by people and more learning, more what is like knowledge work, right? So he also just, by the way, in the chapter, he's like, oh, I solved hunger. The winged bean, which is pictured here, you know, it's got like protein, it's got leafy nutrients, and you could probably use the fibers to like make cloth and stuff or whatever, like hemp fiber. He talks about water management with the fog gun, composting, which is just with respect to maximum possible recycling. You know, it is spaceship Earth, it's a finite system. You know, we're trying to, you know, manage that system, manage the world resources in the most efficient possible way. I'll talk more about that in a bit. So concluding just an analysis of this chapter, he does even a little bit talk about climate change with reference to these, you know, domes over cities, or even just dome over a house with reference to a hurricane or whatever, cooling and heating. Brief points about hygienic problems. So he talks about droplets in particular. I would have liked to have seen him talk about aerosols, but I don't think that was as well understood at the time. About the 1918 flu, you know, would it be a Demaxian astronaut helmet or some sort of umbrella? What does that mean? So just to conclude this chapter a bit, he clearly envisions a futuristic society that is engineeringly, seems feasible, even though it might be a lot of work. It contains breadcrumbs for a computational design revolution, with World Game as the central hub of life. And here's Old Man River City, which he architected or sort of made the reduced to scale model. And he put a baseball diamond in the center of the city. But you might have some sort of World Game, you know, sort of central park or something like that, dedicated to World Game. I would say it's, you know, I've had to bring in several other pieces just to sort of help distill this chapter. It's important to, it's good to know his full canon to the degree that's possible. And if I had to sort of sum the World Game chapter in one phrase, I would say it's computers are the counter emergency. So when there's a big storm where I am recently and I was like checking my phone for the weather report, or do I need to evacuate, right? Computers not only help quell the panic, they can help solve the problem, right? And so I think we'll see that come more and more to fruition. In 1972, he did 10 proposals for improving the world in the New York Times. I think he hit 7 of these 10 proposals pretty strongly in just this chapter in Critical Path. The other 3 are much stronger in synergetics, but he still even does, he mentions, for example, local information harvester, local problem solver in this chapter. So I think he barely get, but you would have to really go to synergetics for more. So I did some academic work on world game. And I would consider the genre of world game, I play video games myself, massively multiplayer online resource management game as opposed to an MMORPG. I make the conjecture that all war and suffering can really be ultimately reduced to problems of resource management. Simulations of better resource flow seems to be simply how the brain works. I argue all thought is simulation. I say apple, there is no apple. It's just a simulation of an apple. And that computers can extend this capability, the simulatory capability, with world game as sort of a crowning achievement, and perhaps a necessary one. I also argue militaries are essentially war game teams. He really makes world game as the anti-war games, right, very specifically. And you could convert those into world game teams, right? I also argue that demilitarization and black market arms trades can only be solved through network tracing if you really think about it. Again, you have to trace these things to be able to find them and stop them, et cetera, and so on. So my favorite part of my thesis is this logical formalism from the completeness theory, from set theory, that basically a database plus a map plus a simulation are necessary and sufficient for all effective procedures. And those are all specific words used in like Turing completeness, et cetera, and so on. The implication of that is that all planetary scale problems are solvable by computer simulation in the manner as described as world game. What I really sort of the reward for the formalism is that, yes, engineering world game is extremely ambitious, but also absolutely necessary through simple logic. We did not evolve as a species with wizard spells or nature magic. We evolved technological power, and world game would be the next step to expand our power, to solve these problems and go into space. And it would also increase our consciousness, giving accurate information, et cetera, and so on. I do play games. I enjoy them a lot, and I get asked, well, it doesn't really sound like a video game to me. There's not really necessarily time to talk about it. There's some stuff here on this slide. Certainly high quality graphics and sort of physics simulation, you could fly, right? But I think this one is important. So Fuller wrote a book called 9 Chains of the Moon, which was really about, if you, at the time, you took the whole population of the planet and you stacked everybody like feet to shoulder, the population would make 9 changes of the moon, right? So that's a simulation that he made based off of data, right? It's fun. It's like a cute idea. And I think you could easily do all kinds of, what if the ocean was made of lemonade or whatever, right? This sort of world game might be able to sort of give you feedback like that, that could be fun for kids, but also be extremely useful for serious, like professional players of sort of this design science world game teams or something. So I also talk about, in the appendix of my thesis, this sort of idea of 2 worlds. So the present world I characterize as just a giant D&D game, right? So the Supreme Court recently has been kind of acting up. They're dungeon masters, right? That's all they are. And they say, Roe v. Wade is gone. And then they enforce those rules through the armed forces, right? Because I could say, well, too bad. And then eventually some policeman or some army man will try and stop me with a gun, right? That's how they enforce their decree, fiat. Fiat is just by decree, right? It's meaningless. And these legal documents, birth certificate or something, right? Which again is it's just paper that the Library of Alexandria burns up, right? Whereas in this MMORPG thing, right, you would enforce the rules through a compiler, through some sort of world game open source code. If I wanted to, access this forbidden thing, I would not be able to if the code is sufficiently strong to stop me, right? There would be no need for someone with a gun or something, right? I think this is a very interesting and important distinction, sort of this D&D world versus a world because we actually have, MMORPGs I love them. I played EverQuest when I was young. I played a lot of them. and they are just Dungeons and Dragons through computers, right? So you could have the same sort of D&D world through computers. And I think it would be a lot better. It seems like Fuller thinks the same thing. So how do you actually get from like no world game, or sort of you could argue that the internet and an iPhone is kind of like a quasi world game, maybe. But so how do you go from nothing to something, to a full-fledged thing? So he talks about kind of a world government, but he doesn't really get into it, it seems like. Personally, I think DeepMind, their AI work, subsidiary of Google, is the best. It's very profound and promising for simulation. Our World in Data, which was on the second slide, they're doing great work with open data sets. They were very helpful during COVID and ongoing COVID. And they also do keep track of population and food and so many other things. So essentially what I would argue you do is you reduce the problems of climate change or war or whatever it is to the degree you can to a 2D data, something that the AlphaGo could look over, and then it could just continue at a hyper speed sort of produce simulatory answers with this idea, whether it's like DALL-E or whatever, right? AlphaGo, beat the Go world master in chess. They also did one for StarCraft, which was beating humans in StarCraft, which was very impressive. I play StarCraft, I'm not that good. But in effect, I would say you kind of need a world game presidential candidate, right? Or kind of a world game like Google or Apple to pitch a project to a receptive government to really do anything. I mean, it's a huge project. So I have like a minute or two left or whatever it is. For bonus points, since writing my thesis at UCSC about this economy business, I expanded a bit. So Fuller really only talks about this non-fictional level of kilowatt hours of the machines and all that. But I kind of, after thinking about it for a couple of years, I kind of think you do need some sort of like a fiat level, right? Where you could accommodate people, you could reward people. Culture could just give people points that don't necessarily have to relate to any immediate one-to-one connection in physical reality of a machine making something or a tea plant being produced. And that's sort of what capitalism is, right? I mean, it's totally, like he makes a point about gas, the price of gas is totally untethered to the real sort of cost of gas. But that this sort of fictional sense could be very useful because it would make it so much more fun, I think. Unfortunately, I think Mr. Nakamoto's Bitcoin is exclusively fictional. It has no real relation, like Fuller does, to supply and demand and production of things in a one-to-one way. 21 million coins is extremely arbitrary. These puzzles are totally useless. You could do non-useless puzzles. Proof of work is an energy hog. I talk about it in that link there, about something a little bit better, very briefly. I say that the Go programming language, which came out of Google also, would be the best. So if you had this standardized curriculum for everybody in the world, right, I would say that you would give them first the Go language, and then they could learn other languages as they like. Similarly, Vyas Houston, who's a Sanskrit teacher, I think Sanskrit would be the best mother tongue, where it's English is the lingua franca, it's the most spoken, but if you actually decide, give everybody a language at birth so that we can at least have one common language, I think it should be Sanskrit for a lot of reasons that Vyas outlines in his book there. So, and in terms of hunger, I think, the winged bean, they talk about moth eggs in Medard Gabel's book. If I think about it, I think it's freeze-dried meals, ready to eat, MREs, because you can get a 50-year shelf life without too much nutrient loss. It'd be like the old-fashioned grain silo idea. We used to store the grain in a big silo. You could do all kinds of things with it. I think it's the way to go. So I think I've just got 1 minute left, less than. On Fuller's gravestone, it says, "Call me Trim Tab." It seems like that this is also a reference, or it's a good coincidence, to "Call Me Ishmael," which is the opening lines of Moby Dick. That's maybe the most famous nautical novel. And it speaks to sort of to Fuller's view of himself, maybe, the spaceship Earth idea, ship, nautical, that he's a sailor on a planet, on a ship, and that, when we all are, right, et cetera, and so on. And also maybe that it's Ishmael and not Ahab might be interesting, but that's for another time. So my thesis committee was instrumental in my being able to think about this extremely ambitious project of world game, but also sort of coming to the conclusion that it's extremely necessary. And that is exactly 30 minutes.